Hello class 11. Today again we are going to discuss chapter number 1. Let us discuss a very important concept which is called resizing and accuracy. Let us discuss what is the meaning of precise and what is the meaning of accuracy. So today's topic is resizing and accuracy. Now let us take a very simple example. Suppose this is a dot. We have to put dots on this point. A person, say let us take an example, Ram. He just throw the dots and all the dots are just hitting the target. We say Ram has great accuracy, means the value is accurate, it is on the target. Since all the values are very close to each other in a very small region, so we say high resizing. Similarly, let us take another boy, Sham. Now Sham, he is throwing the dots and all the dots are just coming here, which is away from the exact value. So we say this boy Ram has poor accuracy, but again it has a great resizing. Because when Sham has thrown the dots, all the dots are meeting at one point. They are hitting the target. Although it is away from the exact target, but they are very close to each other. So we say accuracy is poor because all the dots should hit here, but the dots are hitting far away from the exact value. So poor accuracy, but it has a great resizing because all the values, all the dots are very close to each other. Now let us take another boy, Raman. Now Raman has thrown the dots and they are hitting like this. In this case, we say Raman has poor accuracy and it has poor resizing. So now I think you understood the difference between the accuracy and the resizing. When we talk about accuracy, a value is said to be accurate when its experimental values or measured values are very close to true value. And when the measured values are very close to each other, then we call it precise. That is known as resizing. So this is the accuracy and the resizing. Now here you can see I have written the definition of accuracy. Accuracy is the measure of difference between the experimental value or the mean value of the set of measurements and the true value. So when we say accuracy is the difference between the mean value minus true value. That is exact value of the measurements. If the value difference between mean values and true values is 0, we say absolute accuracy. So accuracy is the measure, or it is a difference between the experimental or mean value of the experiments minus true value of the given experiment. On the other hand, we have written here resizing. Resizing is simply defined as the difference between the measured value and the mean value. Keep in mind here we are taking about measured value and arithmetic mean. Mean means first we calculate the mean of all the measurements and then we subtract the given value from it. So when we say resizing is equal to measured value or we can even write here mean value minus measured value of a given quantity. So that is the difference or the definition of accuracy and precision. Now, after doing accuracy and precision, we are moving towards a very important topic, which is called we say significant figures. So the next topic is significant figures. Let us see what are significant figures, and we have some rules to find the significant figures. And when we add or subtract or multiply or divide the significant figures, we have to follow some rules. We will discuss those rules also. So the first topic we are going to discuss is significant figures. Significant figures generally contains all the values with absolute accuracy with the last digit uncertain. Keep in mind, the last digit is uncertain, whose value we do not know with exact accuracy. So when we say significant figures, significant figures are simply defined as the set of all the certain digits in a given number plus the last digit is uncertain. Let us take a simple example. We have 245.49. Here, these all are significant figures. We know their value with absolute accuracy. So we say these all are significant figures. Now keep in mind the last digit should be uncertain. So significant figures contain all the digits in a number with certain value or whose value is known with absolute accuracy plus the last digit uncertain. Now we have some rules to find significant figures, and that rule we use only for zeros. The first rule says all non-zero digits are significant. Keep in mind, all non-zero digits in a number are significant. Like 2, 4, 5, 6. We say number of significant figures in this case is 4, because these are non-zero. 2.4567. How many significant figures it has? All non-zero significant figures, all non-zero digits are significant. Here 1, 2, 3, 4, 5. So we say number of significant figures are 5. If we take 1, 2, 3, 9.227. Now how many significant figures does it have? If you count, it has 7 significant figures. 1, 2, 3, 4, 5, 6, 7. So we say 7 significant figures. The first rule says all non-zero digits in a number are significant. Now this is the first rule. Now we move towards second rule, which simply says second, 0 between two non-zero digits are significant. It means if we take 0 between two non-zero digits, then that 0 is also significant. For example, 1, 0, 0, 2, 3. It has 5 significant figures. If we have 1, 0, 0, 0, 0, 0, 1, then it has how many significant figures? 1, 2, 3, 4, 5, 6, 7. So 0 in between non-zero digits is always significant. Let us move towards the third rule. Third rule says 0 before non-zero digits is non-significant or unsignificant. What does it mean? If we have 0.0257, then it has only 3 significant figures. 002507. How many significant figures it has? Yes, 1, 2, 3. This 0 is significant because it is coming between 2 non-zero digits. Similarly, we take another number 0.025770. Now, keep in mind the zeros which comes before or after non-zero digits are non-significant. So here we have 4 significant figures. We will not take this one as significant figure. Now let us move towards another rule. If a number is given like 0.0250, now keep in mind when we have decimal, the 0 which comes after decimal, after non-zero digit is considered to be significant. But if the 0 comes before decimal or before non-zero digit, then it is non-significant. Here, how many significant figures we have? This is a non-zero digit, decimal has come. This is not significant, non-significant. But the 0 which comes after decimal, after non-zero digit is significant. So, how many significant figures it has? It has 1, 2, 3. 3 significant figures, or 3 significant, we say it has 3 significant numbers. Now, let us move towards another example. We take 1.00200. How many significant figure does this number has? Keep in mind the zeros after non-zero digit are always significant, and after decimal the 0 which comes after non-zero digit is also significant. So here 1, 2, 3, 4, 5, 6. So we see it has 6 significant figures. If we write 0.002010, how many significant figures? It has 4. If we write 002001, it has 4 significant figures. So these are few rules to find the significant figures. So we have seen that how to find the significant figures. Now, when we do addition or multiplication of numbers in significant figures, there are also some rules which we have to follow. Before doing that, let us revise again. Find the number of significant figures in given. We take example 0.02033, 0.00203300, 10.0230, and 1.0047. Now, how many significant figures do we have in this case? These are not significant. 1, 2, 3, 4. We say it has 4 significant figures. How many this has? These are not significant. 1, 2, 3, 4, 5, 6. It has 6 significant figures. Here, how many? 1, 2, 3, 4, 5, 6. And again has 6. And this one has 1, 2, 3, 4, 5. 5 significant figures. So these are the ways how to find significant figures. So tomorrow we will discuss about how to do addition, subtraction, multiplication and division of significant figures. Till the time, just divide it. Thank you.